Okay everyone, so this is the next lesson on rearranging equations or changing the subject, and we're going to complete these 6 examples in our book, so make sure you get these copied down. So in these 6 questions we want to make x the subject. So we're looking to make x the subject. And for this first equation, x squared equals y, I can see, you might think, oh, x already is the subject of this equation, and I can see why you would think that, because x doesn't have anything being added to it, it doesn't have anything being subtracted from it, it's not being multiplied by anything, and it's not being divided by anything. But x is being squared on the left-hand side of the equation, and we don't want x squared to be the subject, we just want x to be the subject. So we have to do the inverse or the opposite of square. Now the inverse or the opposite of squaring something is square rooting something. So we want to square root both sides of this equation. Now squaring and square rooting are opposites of each other. So they cancel each other out and leave us with x. This is the left-hand side. On the right-hand side, we are left with the square root of y. And now we have made x the subject of the equation, because we just have x equals something. Okay? So in the next one, we have x to the power of 4 equals y, and we want to make x the subject. We just want x to be the subject, nothing else. And when we had x squared, we had to do the square root. Now when we have x to the power of 4, we have to do something called the fourth root. And the fourth root will look like this. It's exactly the same as a square root, except we have a little 4 here. And we have to do that to both sides of the equation. So the power of 4 and the fourth root are opposites of each other. They cancel each other out and leave us with just x. And on the right hand side we have the fourth root of y. And that is the answer to our equation, to our question, because we've made x the subject now. For the third one, we have x to the power of 4 equals 2yz. And again, we just want x to be the subject. We don't want x to the power of 4 here. So we have to do the fourth root again, because the fourth root and to the power of 4 cancel each other out and leave us with x. And whatever we do to one side, we have to do to the other. So we have to do the fourth root to the other side as well. And that gives us an answer of the fourth root, x equals the fourth root of 2yz. And that is the answer to that one. The next 3. Over here we have x squared equals y plus z. Now we just want x to be the subject, and we can see that x is being squared, so we have to do the square root, because the square and the square root cancel each other out and give us just x. And whatever we do to one side we have to do to the other, so we're going to square root the other side as well, and then we have an answer of the square root of y plus z as our answer. Next question. We have x squared equals y over z. And again, we want x to be the subject, just x. X is being squared, so we must square root. Squaring and square rooting cancel each other out and leave us with x. And if we do the square root to the other side of the equation, then we have the square root of y over z as our answer. We can also write this one slightly differently. We can have the square root going over the whole fraction, or we could have the square root going over the numerator and denominator like that. And sometimes that will be useful. In this question it isn't, but sometimes writing it like this will be useful. So just want you to be aware that this one can be written in two ways. Okay, and this last question, we have x squared again. So if we want to make x the subject, then we have to do the square root, don't we? Because that's the inverse of square. They will cancel each other out and leave us with x. And then we're going to have to do the same thing to the other side. So we have to do square root of 25y, the whole thing, 25y. So I'm going to have the square root of 25y. Now, this one can also be written in another way. And in fact, I'm not going to put a box around this, because this, we shouldn't really leave it like this as our final answer. I don't know if there's much point trying to tip x out my box. But I shouldn't really leave it like this, because so I've got x equals the square root of 25y. Now, I actually know what the square root of 25 is. The square root of 25 is 5. So this one, I should be writing it as x equals 5, because the square root of 25 is 5, root y. I don't know what the square root of y is, so I have to leave it. But I do know what the square root of 25 is. So leaving it like that is much, much better. So you're going to do 6 practice questions now by yourself. So on this slide, you're going to be making V the subject. So here are 6 questions for you to have a go at. So pause the video and have a go at them. And the last one you can see is in a different colour, because I want you to think about, just think about your final answer for the last one. So pause the video now and have a go. Okay, so we're going to go through the answers. So we want to make V the subject, and in the first one we can see we have E equals V squared. So we have to square root both sides to give us root E equals V, and V is the subject, so we've done it. In the next one, again we have V squared, so we're going to have to square root both sides to give us root 7E equals V. Now we don't know what root 7 is, 7 isn't a square number, so we just have to leave it like that. Notice as well how the line of my square root goes over the whole of 7e. It doesn't stop after the 7, it goes over the whole thing. In the next one I have v to the power of 5, and the inverse of the power of 5 is the 5th root. So I have to do the 5th root to both sides of the equation, and I'll get the 5th root of 7e equals v. In the next one we have v squared over here, so we have to square root both sides. So we're going to do the square root of 7 plus e equals v, and again notice that my square root is nice and long, it goes over the whole thing, like that. Next I have 4 over pi equals v cubed, so that means I have to do the cube root to both sides. So I'm going to write it like this, the cube root of 4 over pi equals v. Remember, you can write this one as the cube root of 4 over the cube root of pi as well. I didn't do that for this one. For the last one, we have to square root both sides. So we get the root of 4 over pi equals v. Now remember, this is actually equal to root 4 over root pi. And similar to the last question in your example, you actually know what root 4 is equal to. The square root of 4 is 2. So for this one, we should be getting 2 over root pi equals v. Because the square root of 4 actually is 2. We know what that is as a number. So, we're now going to go through these 6 examples, which are really similar to the last ones. So, get ready to copy these down. So, in these 6 example questions, we want to make H the subject. And I can see that in my first one, it does kind of look like H is the subject, but actually the subject is the square root of H. and we just want h to be the subject. We just want h by itself. So the inverse of the square root, to get rid of this square root here, it's gone a little bit blurry, to get rid of this square root here, we have to do the inverse of the square root, which is the square. So when we square a square root, they're the opposites of each other and they cancel each other out and leave us with h. But whatever I do to one side, I have to do to the other. So I'm going to square both sides and I get h equals x squared as my answer. Next, I want to make h the subject of this equation, and I can see that h is inside a cube root this time. So to get h by itself, I have to do the inverse of the cube root, which is the cube. So these two cancel each other out, the cube and the cube root, and leave me with h on the left hand side. On the right hand side, I need to cube this too, but I have to be really careful here because I'm not just going to do this. My answer isn't going to be x plus 2 cubed. That would be wrong, because I need to cube the whole thing on the right hand side of the equation. And the way I show that I'm doing something to the whole thing is I use brackets. So I have to cube everything on this side, not just the 2. Without these brackets, you're only cubing the 2. So we have x plus 2 all cubed is the answer to that question. H equals x plus 2 all cubed. Okay, the next one, I want to make h the subject and h is inside a square root. So that means I'm going to have to square both sides. So when I square a square root, they are the opposites and I just get h. And remember, I want to square the whole side. I don't just want to square the 2. If I do this, I'm only squaring the 2. I want to square the whole lot. So x plus 2 all squared is what I get on the right hand side, and I've made h the subject, so I'm done with this question. In the next one, I want to make h the subject and h is inside a square root again. So to undo that, to get h by itself, I'm going to square that side, and I must square the other side. So this is another one where I have to be really careful. If I just put this here, then I'm only squaring the y. Okay, I'm only squaring the y if I just put my squared like that. I need to do it to both the x and the y. I need to square everything, and I show that with brackets. I need to square everything on that side. So I'm going to have xy all squared equals h. You have to be really careful that what you're doing to both sides, you do to everything. The next one, we want to make h the subject and h is inside a square root again. So that means we're going to square to get h by itself. And again, I'm not just going to put a 2 here. I need to square everything on that side of the equation. Everything. So I'm going to use brackets because I need to do the whole of 2x all squared. Now this one I can write slightly differently if I want to. I can write h equals, I can have 2 squared x squared, and I actually know what 2 squared is as a number, so I can even write this one as h equals 4x squared. It's similar with this one actually. This one I could write this one as h equals, I can have all of xy squared, or I could have x squared y squared, like that. Okay, so both of these are acceptable answers, but this one we should be writing it like this, because we can do 2 squared. That is something that we can do, so we should do it. And then this last one, I have the cube root of h equals x over 2, and I want to make sure that I make h the subject, so I have to do the inverse of the cube root, which is the cube, and that gives me just h on the left hand side. The right hand side, remember, we want to cube everything, And when we want to do something to everything, we use brackets, because I shouldn't just do this. If I do this, I'm only cubing the x. I want to cube everything. So I can write my answer like this, x over 2, all cubed. That's fine. Or I can write it like this, h equals x cubed over 2 cubed, which I can do 2 cubed in my head. It's 2 times 2 times 2, so it's x cubed over 8. So you're going to have a go at 6 questions by yourself now to practice what you've just learnt. So in these questions you're going to be making R the subject of the different equations. So you have 6 questions here. And again, for the red one, you want to just be thinking about your final answer. So off you go. Pause the video and have a go at these. Okay, so for the first one, we want to make R the subject. R is being square rooted, so we square both sides to get t squared equals r. In the next one, we have the 4th root of r, and we're going to need to do the power of 4 to both sides to get t to the power of 4 equals r. In the next one, we have root r, so we're going to have to do, we have the square root of r, so we're going to have to square both sides, and that's going to give us 5t all squared equals r. For this one, I think we probably should be writing this as 25t squared equals r. So we're going to, let me show